the company is now ready to pull out the wand of truth, being the drill rig, and test these geophysical targets. We're looking forward to see what comes out of the drill hole. My name is Dr. Jason Myers. I'm a director of Resource Potentials. We're a consulting firm based in Perth, Western Australia. We provide primarily high-end geophysical data processing, modeling, and interpretation, and we also love to integrate geology and geochemistry to help our clients with their targeting. We've been approached by First Development to assist them in their exploration in the Wallal embayment or basin in the Pilbara region of Western Australia. FDR are exploring for an analog to the Greatland Gold Havieron gold copper deposit, which was discovered in the 1990s, around 1993, but has been more recently drilled over the last 2 years and has turned out to be a world-class gold deposit that is quickly being developed. The Wallal embayment runs in the same Neoproterozoic geology, extending from Havieron and Telfer. Undercover, the Wallal embayment itself is a deep sedimentary trough, primarily filled with Phanerozoic sediments, which have been previously explored for oil and gas. Some shallow holes have been drilled in the basin, and on the flank of the basin is a shelf still covered by sediments, but with the same bedrock geology that hosts Havieron and Telfer, sitting undercover. There have been very few drill holes in that part of the world, but it is closer to the main Northern Highway and the coast in WA. That target area that FDR have, First Development, is primarily a magnetic anomaly, very similar to the anomaly that led to the discovery of Havieron. There's two other magnetic targets in the same project area. One of them is quite deep. We know that now from reprocessing and interpretation of seismic reflection data. But we know that the cover sitting over this, the strongest magnetic anomaly in FDR's ground, sits at about 600 meters of cover. It's a little bit deeper than Havieron, which is at about 450 on average, 400 in the shallowest and pushing 500 in the deeper part. Because FDR is exploring in a very deeply buried environment, this is what we call, deep exploration or deep undercover exploration. We have to rely on as many technologies as possible before testing targets with drilling. So we've gone through existing open file magnetic and gravity data sets and really pushed them to the limit to pull as much information as we could out of them and assess depth and geometry of the source of these anomalies. We've reprocessed seismic data, as my colleague Nigel will talk about. We carried out passive seismic, and there's been some recent reconnaissance activity and heritage clearing. So the work that's been going on the background for the last 6 months or more, the company is now ready to pull out the wand of truth, being the drill rig, and test these geophysical targets that have this similar geological setting.
Yeah, so just to give you a quick rundown of Resource Potential's involvement in this project, we started an initial desktop study in Q1 of 2021. We quickly identified that there were some key magnetic bullseye anomalies with similar characteristics to Havieron, similar shape, similar amplitude, and maybe a little bit broader, possibly sitting a little bit deeper below cover. Similar appearance to Havieron, but in a similar structural position to Winu. So we're quickly excited by one target in particular, which we've called the main Eastern magnetic anomaly. Based on the local and the regional geology, we're expecting these magnetic sources to sit several hundred meters below Phanerozoic sedimentary cover sequence, but hosted within a prospective Proterozoic bedrock geology. As part of this initial study, it was just imaging, processing, modeling, and unconstrained 3D inversion modeling to give a rough idea of the depth below surface. So based on that initial study, for this main Eastern magnetic anomaly, predicting maybe 600 to 700 meters below surface. But really, it's just a rough guess at this stage, and we needed to do further study to try and constrain the depth to the target and give a more realistic drill proposal. Okay, so a follow-up study that Resource Potentials has carried out involved making the most of historical exploration data, namely 2D reflection seismic, and acquiring new data over the top of the magnetic targets, in particular the main eastern magnetic target, in order to constrain updated inversion modeling, magnetic inversion modeling. So to start with the 2D reflection seismic, we worked with the WA Government Geological Survey to obtain that data, convert it from a tape format, and got it sent to Val size on the east coast of Aussie to reprocess the data and provide us with some depth converted sections. So converting the seismic data from time domain into depth domain, and so that we could interpret stratigraphic layering within the cover sequence and interpret the depth to the Proterozoic basement. Historical 2D reflection seismic didn't cover the main magnetic eastern target, and so we proposed and carried out a low-cost and effective non-ground disturbing passive seismic method to estimate the thickness of cover sediments. So this was carried out by Atlas Geophysics, and 3 survey lines across the key targets and overlapping with the 2D reflection seismic were carried out late last year. So the aim with this data is to identify reflectors, deep reflectors within the cover sequence, and relate these to reflectors that we're seeing in the 2D reflection seismic, to integrate these data and then predict the depth to basement in the area of the key magnetic targets. Okay, so we're in later 2021 now. We've reprocessed the 2D reflection seismic. We've acquired and processed the passive seismic and integrated these data in 3D workspaces. Next step was to carry out a constrained magnetic 3D inversion modeling. So constraining the model, the magnetic model, forcing that model to sit below the interpreted basement, top of basement, and through doing a constrained inversion, now we've got a much better understanding of the depth of the target, and we can see some variation in the shape. It's likely the magnetic source is likely composed of 2 lobes, and that we'll use that information in drill targeting. And the depth to the top of the source, magnetic source, is likely around 800 meters. So a little bit deeper than the initial unconstrained inversion. So we've now been able to very cheaply and with minimal work on the ground, been able to provide a much better constrained target for drill targeting. And that's where I sort of handed over my work, and the ResSpot Geo team started to work with First Development to assist with planning the drill program.